All right. Good morning, everybody. Thank you all for coming. It's a wonderful event and wonderful community as well. So I came here today to talk about this project. It is, my pet project that I'm actually obsessed with, and it is to try to solve a long-standing problem regarding RPC node scaling, and it's called EVM.lua. So my name is Everton. I work for AWS, but before that, I spent almost 5 years at the Ethereum Foundation. So I worked on the Mist project, the wallet, Ethereum JS, and a few other projects internally, including the DevCon website and blog. So, doing a little bit of everything. We learn a lot. And actually, working for AWS now, some folks might wonder, well, why AWS, right? Actually, it kind of gives us this interesting opportunity to work and do stuff like this, right? So to take, Ethereum data sets, make them publicly available, and folks can download and run for free. They can query using Athena. It's running since 2022. Not a lot of people know that, but don't make a lot of noise. Also, we have, AWS programs for startups, Web3 startups, that we're actually partners with the Ethereum Foundation. And the EF, if you're a grantee, you can have AWS credits to build a company there, right? So that's the type of interesting work that we kind of unlock once we have, somebody that came from deep ecosystem to a cloud company like that. That's super powerful. And also stuff like this. This was not created by me, but it is from the same team. So we have a team of other experts, and they're building, just a lot of acceleration to run nodes of, 14 protocols and on. All right, but back to business. So this talk is really about challenges on RPC scaling, and a problem that I can, of course, observe from the customers that run their Web3 workloads on AWS. So we have the privilege of working with Coinbase, Binance, Crypto.com, but also a lot of DeFi folks, right? So some of them I can even name, like 1inch, right? Those folks are on AWS. And the common theme is, how do I scale my nodes, right? Eventually, that work, ends up being delegated to a service provider, like the ones that we know and love. So I went on, trying to explore this a bit deeper, and so some of those challenges were, if you have a lot of requests coming up overnight. If you're scaling, you're a DeFi player, that happens a lot, right? You scale overnight, a lot of pressure on the RPC, right? If you're running a lot of predictions, ETH calls, and stuff like that. So horizontal scaling is what people revert to the most, right? That means if I have a lot of demand for those ETH calls or those RPC calls in general, let me just add more and more blockchain nodes of the same type to handle the peak of access. But that creates three problems, right? One of those is the reaction time. So the time that it takes from your access pattern to increase, your demand to increase, then you need to have fully ready RPC node able to handle all those requests. So that includes a lot of technical work, managing snapshots, loading chain data, the sync time, and consistency checks, health checks, and all that. Second, forecasting. If you don't want to really over-provision on scaling a lot, you have to be really, really good at forecasting your access patterns. So then you scale intelligently and don't spend more than you should, right? And the final boss of that, which is a big problem as well, I would call it the routing consistency. If folks are trying to access nodes, there is quite a few challenges if you need to route them to the same server always, all the time, or if you have a global consistency problem because each node syncs independently by design. Welcome. So, if we dig a bit deeper and try to see what is the actual use cases folks are using RPC for, and you do a breakdown of them, you can kind of come up with a model. There's certainly a pattern here. You have some methods that would always kind of return the same thing. This static, no parameters. So per a specific given chain, it will always be like that. Block numbers, well, it is kind of a function of a single parameter anyways, right? You can also have things like get logs, fee history, ETH call. Those are kind of different things that happen on the back, right? So here with fee history is basically a computation of the latest blocks, right? And ETH call is, a bit more involved. I've seen a lot of folks in the space trying to scale. They try to just come and cache a lot of these things here. This is kind of the 3 first. And although they can, really effectively cache that, it's not really hard. But then you have, some sorts of problems here, because ETH call is really the big boss, the big enemy, right? Because this here is basically for every token balance call you're running an ETH call. Now, how many times you're gonna query your, uni balance of the block 5 million? Most likely only once, right? And then when it comes to the next block, then you have a different call here. So the cache miss-hit ratio was really unbalanced here for ETH call. Just to give a number, one of the customers, they try to cache, as many methods as they could. They could only have a cache hit-miss ratio of 17%. That's suboptimal, right? And we know that ETH call is really more demanding and involves, heavy computation side. All right, so we can definitely try to cache a lot of things, but if you want to tackle a problem, why not jump into the hardest part first? That's kind of a more personality-wise, that's kind of a bit of me, but why don't we try to really externalize the state? That is, kind of an interesting idea, because you can just put a database, and then you can have your virtual machine calling, making those as-load calls. But then you might run into some other issues. Main issue is with the latency of the reads, right? So, and then I was kind of exploring to see is there an opportunity to actually have execution and storage on a highly scalable, database type with minimal latency for S-loads? And it turns out that the answer was there, always. So we basically, I was basically exploring to use Redis to store the state for each of the contracts. And I would have a first load of the data into Redis. Then I'll get into more details a bit later. But having both the contract code, storage, balance, nonce, that is all you need, plus some of the block metadata. That's actually all you need to execute an ETH call, right? So that's what I did. So users can, still call geth, but they can also call Redis for their EVM interpretation side. But how do we actually make this work? So Redis has this extensibility feature that allows you to embed Lua, which is an interpreted language, arguably one of the fastest one we have today, with performance that approaches to C, right? And, game on. Yeah, I had to implement a bunch of bytecodes and do the first test. On the first initial test, it was like, more or less 40% faster than geth, even without loading any data from smart contracts, right? And so that's what I did, right? So I had to copy a lot of the data from contracts with all the storage keys into Redis. And here's one interesting thing. If you have, let's say, a DeFi protocol, you actually don't need the full blockchain data to make your calls. You can only have the ecosystem of your own contracts loaded to this external interface that is plugged to your own running node. If you trust the setup enough, right? That can allow you to really scale horizontally with Redis in a much faster pace. There's certainly a lot of innovation in the space these days, right? With Wrath, with Bezu, they have this Slim node right now. But I think this is still a valid approach because it allows you to actually load what you're going to need, much more like a cache mentality, right? You want to load into the cache environment what you actually need, then you start using it. So here's the project. Today it's called EVM.lua. I did a technical validation. It actually, it works. It is a micro EVM interpreted, implemented in this language called Lua. It was created in Brazil, actually, my country, right, and Leonardo's as well. It executes inside Redis, making really minimal, right, the latency for reads. And well, it is actually able to interpret ETH calls. Not only that, but if you're estimating the gas for a transaction, that's actually also an ETH call model. It's just a return type that is different. Same with debug trace call, right? And so many other methods that are actually around just running EVM code. So ETH call, I picked this one because it was really the biggest problem, the biggest villain over there, but it can be easily kind of extended to other use cases and EVM intensive calls as well. Now, I'm actually so just for the deep technical minds here, the prerequisites for execution node, if you want to run it outside of Geth, you need to have debug trace block method, you need to have a pre-state tracer, and I do this using diff mode true, which gives me for each block, I got one call to the RPC, and then I list all of the storage keys that changed from all the contracts that had changes. I can selectively load into my database what I want, what I need, and call it a day, and for only one call per block. So that is very interesting. I've seen this done differently, so tracking state changes in different ways, and I think that really keeping it very simple here, it would be key, right? Of course, that for a full production implementation, you would also need block metadata, right? Because from the EVM, you can also have access the block hash and a lot of other block metadata and blockchain context there. So I believe that we are something in between, but already here, because we have over 100 opcodes implemented, but there are some key things here, like add the proper metering, integrate the official EF tests into it. So I'm actually testing on the optimistic side today, right? So integrating with the real tests is it is the challenge here. And the deployment phase, it would involve the actual full-fledged benchmarks, the optimization feedback loop, which is, man, you just put it to run and understand the hot paths and to try to optimize each of these segments. And most importantly, because it all ties back to the user, try to see what are the use case specific features that are needed there. Why folks would actually use it for? Is it to actually simulate transactions? It could be done using it, but it might require some steering on how this is implemented. So this is not the benchmark of that project, but this is the upper bar of Redis, right? So this is a benchmark that was done on AWS using the service that is basically managed Redis, Elasticache. And folks were able to run with 1.2 million requests per second. Those were actually very simple calls. Now we're talking about EVM calls. But even so, that kind of gives us some sense of scale here. And that is a single node, right? And that is a single, and that is a cluster right? A cluster of that node with the replication on the database would handle all the replication for us, in this case. It can actually surpass 500 million RPS. So that kind of brings me to a philosophical moment here of, hey, if you don't actually need to have the elasticity of scaling horizontally within your company, within your project, would that make it easier for folks to manage 1 or 2 Ethereum nodes, right? Can we kind of, what is the opportunity here for the individuals that are using Ethereum today, right? Or EVM in general. So that's kind of the thesis of it. And I think it's really important that us at this stage where the whole blockchain thing is validated, right, is for us to zoom out and see what are the opportunities for us to integrate to other long-standing platforms. And I think that was a good exercise. If you folks want to give a follow, want to see what's going on with the project, we'll be posting updates there. That's the GitHub project of it. And thank you. We can take questions if time allows.
When you say you wrote like a microinterpreter in Lua, what's the micro part? Is it like a selected subset of opcodes, or?
Yeah, thanks for the question. It is around 112, 117 opcodes out of the 150. Yeah, that's the micro part. Yeah, but I have to tell you that that not the most daunting ones are implemented. So that's to get to that number wasn't particularly hard, right? There's a lot of pushes. I love that. Yeah. Yeah, exactly. Yeah, so the arithmetic, there are still some challenges there because the Lua version that's loaded into Redis is not fully capable, and then even the arithmetic can be tricky, right? So implementing EVM is not a trivial job, right? You got to really lean into the edge cases. The happy path is really happy; it's really fulfilling, but the edge cases are everywhere, right? It's a landmine.
Thank you.
Right.
So just wondering if it could be supported to do like subcalls, so static, delegate calls, these kind of things.
That's right. Yeah.
Storage loaded or.
Yeah. So that is a very good. That's a very good question because it will be possible to do these static calls and to do the nested calls. I think it is nowadays it's paramount, right, for you to implement something like that because most of the contracts, the relevant ones are under proxies, and that's a needed one. I think that in the fullness of time, there might be even a feature I was thinking about is, hey, you load an ETH call code into a script, and then it would actually understand what are all the contracts that ETH call typically uses, or it can monitor that using your main infrastructure. And then you can load those contracts on demand into the Redis side. And if the Redis doesn't have access to the storage of that contract, it would just kill it and have Geth serving as a backup. So it's definitely, I think that's a clever question. So, thank you.
I know that some chains, they do try to outsource this job to some custom indexers, for example, Solana or Aptos, and then saying, hey, it's up to the client to configure the indexer in the way they want to access all the indexer is working. It's basically indexing all all the data that this particular application needs, and then you're just using GraphQL to just retrieve from the index. What is the difference of this approach to what you described?
Very good question. So there's definitely increasing demand for specific access patterns for blockchain, right? So that's a great question. And I think that this here would actually shine on the DeFi space because you need to have, real-time applications. Sometimes those data indexers, it might be, there might be some challenges to catch up. It is very sophisticated infra to make, Solana indexer work live, right? If we're talking here about, hundreds of milliseconds of block time, right? So it might be very challenging for real-time data apps to catch up with the index. And I think, well, there's a difference between accessing state directly and using ETH calls. That's the EVM interpretation, right? So you really simulate how would a Uniswap trade would look like under a variety of trade paths. And you could do this with theoretically lower latency, right? So we'll get there. Thanks for the question, very insightful.
Hi, two questions. One, how do you deal with when your nodes don't end up on the canonical path? Because it does happen. The more you run, the more it happens. You end up with some data that you index, especially if you try to stay at latest block. Do you have like methods to deal with that? And the other side was, did you ever think of just altering the way GoETH stores data and taking that path rather than re-indexing?
That's right. Two great questions. So I don't have full data schema implemented that would allow a revert be, quick enough to support it. So what I have today is, again, the optimistic data loading. But I'm thinking about using the diffs that I take for each block and to actually reverting that and be rebuilding it, right? So that would be kind of a step ladder. If you're, let's say, 3 blocks behind, you kind of try to revert it, because the pre-states tracer actually shows me what were the values before. So that's incredibly valuable. So whoever designed that pre-state, that was a good job. So that allows it to reverse what was once truth, right? So.
Okay, and you'd use maybe some consensus between your own nodes running to decide on the canonical block or something like that?
I don't today, but I think it would be reasonable to do so as the criticality of the use case permits, right? And to your second question, would that make sense to have it embedded into a proper client? I think it would, right? I think it would. I think innovation happens like this. You try to prove something that it works outside of the main environment, and then folks come and incorporate. I have no personal love about the project to the point that, hey, I'll try to have it, own it myself. No, if anybody wants to take it, that's it's open source for a reason. Thank you.
Thank you.
No, next question.
Oh, okay. All right. So we're out of questions. We're out of time. I think it's a good match. Okay. Thank you very much. Have a good day. Bye-bye.
Thank you.